Oh, what is this?
Yeah.
Caliber?
A micrometer. We don't have any what they call inside mics. These are called outside microphones. And this is unique in that we can change out this guy right here. This is called an amble. And so we can get on this one, we can get anything between 0 and 4 to 0 to 4 inches. This one's in inches. The ones that we'll play around with in lab are going to be in millimeters. They're going to be using the metric system. We're going to use the one that's in our in these kits that we have available on Bosch units back there, where it's called precision measurements. So what we do on this, of course, is we make precision measurements on this. So anvil, frame, right? I might have to look this up and see what this is. But you notice when you turn it, this is what I was looking for. So somewhere on this thing, you have a 0 line, right? See the 0?
Yeah.
Okay. Everybody okay there? You'll see the 0? Okay. So this, we use this to course adjust it, and then when we get close, we move down to the little bottom one down here, and we turn it until it clicks. Y'all hear that? Okay. So this is our course adjust. Okay. And then what do? Once we get close, we move down to the little thimble down here at the bottom, and then we just keep turning, and then when it clicks once, that's where we stop. And that means it's flush. And if we look at our measurements, if it's calibrated, then your 0 on your thimble should line up with the 0 line on your mic. You see that? So this is, we got some reflection. Let's see if I can get this. Yeah. So here's 0. Then we have 0 here, right? Does that make sense? Okay.
What is over just a little bit?
What's that?
It goes over just a little bit.
If it goes over just a hair, then we could calibrate it, but that's all right for now. Are we okay? So what we'll do is these are our standards right here to verify. So I've got the small one. This should be 1 inch. So let's look at the scale right now. So what we have is this is in milli inches. Yeah. You want to go ahead and you want them to go ahead and get their fit loss mistakes, sir?
They can do that.
Let's go ahead and pause this, guys. We brought some easier for me to show you then, but you can use your micrometer while we're doing this. Okay, and give it a look. So we're looking at, this is actually for another class. That's okay. I need to change this over. This is called a micrometer, right? You measure outside. You can't do inside diameters with this one, but we do have another one that we have the ability to do that with. It's a vernier caliper. Veneer, and we'll show y'all that in a minute. So these are different types of micrometers. And this is the one we're looking at right here, which is, we call this an outside light. So the only thing we can do on this one is measure the outside distance between something, right? You understand? Makes sense?
So are these kind of like calipers that measure like the thickness of metal and stuff like that? You know what I'm talking about? They got like the digital ones. So I got the digital one where you can.
Yeah, but it's just like digital's fine, right? But we'll see how to do this one, right? And then if you can do these, you can do the digital. Are we okay? Yeah, but you don't know what you do. So here's the parts, guys. So we have the, this is also called the ample. This is called the frame. You got the rod, thimble, and the ratchet. Okay? That makes sense? Everybody okay? So the thimble rotates, so we'll move the thimble around until we get close, and then we'll move back over to the wall. The ratchet cap, and we'll adjust it till it clicks one time. Everybody okay? Any problems? So this is the way the scales are set up. And it measures in millimeters. So what we have is this would be 0.1, this would be 0.2. Everybody understand that? 0.3, 0.4, 0.5, 0.6. Everybody okay? And then each minor division, this would be point 0.025, this would be 0.05, right? Yeah, 0.75, right? No, I'm sorry, this is wrong. This is 1, so we got 1, so I didn't see it, that's right. So this would be what? 2.5, this would be what? 0.05, because this is the measure. I understand what I'm saying. So let's measure what we got and see what we got. So what I did is I'll come up here and I'll see the last division I have. So what I would do is I would come down here and I would start writing a 2. So this would be 0.2. Everybody okay? So that's the last thing I see. Everybody understand that? Then I'd come over here. I can see one division. So that's going to be 0.25. Everybody okay? And then I would look at the thimble. How many do we have on the thimble? I'd have to look. Okay. Well, we got to figure out what it is, right? So there's 20. So there's 25 of these. So what I would do is this would be 16. And where would we add that to? That's going to be added right here. So I'm measuring 0.02. Oh, I need to go the other way now. This would be 1.3. So 231 milli inches. Oh, I can't do math, thank you. And that's how we measure it. That makes sense? Is it hard? What's that? You say kind of. So what we do, first of all, is we look at the major divisions, right? Everybody understand that? So the biggest one I see is what? 2. So that's going to be 0.2. Everybody okay? Then I look at the minor divisions that I can see. And how many can I see? I can only see 1, right? So that's going to be what? 0.25. Everybody okay? That makes sense? Okay. Then I'll read my thimble. And I would come and add my thimble to this last. This is 16. It's either 16 or 14. That's what I wanted to do. Well, it depends on which way it turns. We can't see the next measure. So it's one pass and it goes up. So that would be 16. So this guy here would be accurate to 1,000ths of an inch.
Okay. This is
Yes. No, this is inches. So that symbol means inches. So this is we're looking at. Now, if, y'all go back and get one of these guys right here. I'll have to do a look on it. You should be back by the boss. So everybody got someplace they can sit by? What's that? Pretty nice kid, ain't it? This is for precision measurements, but this has everything we need to totally tear those skill boxes apart like that. And then plus also do maintenance on, right? You know what I'm saying? Now this one is in millimeters, right? You understand that? Everybody okay?
Millimeters?
Millimeters. So that means if I turn it out until I see 1, then what would be up from a 1? So this is 5, I'm sorry.
0? 5, 10, 15, 5.
So 10 would be
100.
1 centimeter, right? Because that would be 10 times millimeters. That would be a centimeter, right? You understand? So the 1 would be 1 millimeter. So if I was to get this guy right here, this is up in the top. You'll notice you got 2 rulers. And this is the machinist ruler right here. No, the short one. And a machinist, now this is in millimeters on one side, a half a millimeter on the other side, right? You'll see that? Makes sense? Okay. So this 10 right here, what would that be? That would be 1 centimeter, right? You understand that? Okay. Now we can't get this in here, but we can come over here right now. So I've got mine on 10, and then I'm going to line up to 0, right? And then I'm going to come over here and put this in here, and you can see that should line up really close to the 10, right? So that means that would be 1 centimeter. Everybody okay? That makes sense? Yes or no?
Are you talking about just the edge spaces between the two?
Yeah, this is what we would actually measure. This is where we put what we want to measure.
So
let's
put this on 10?
No, that's what I'm trying to show y'all, that it is in millimeters and centimeters. So when I come over here and put this in here, you know, see what I'm doing? It lines up. I've got mine on 10 over here, right? At 10 and 0. I know the light's shining on it, guys. Right? Y'all understand that? So can you, right? So you need to line this up right here on 0 on the line. You need to have the last thing you see is 10. Then you line up to 0. And then if you put the ruler in here, it shows me 10. Right? You see what I'm talking about? Yes or no? Okay. So what would each one of these things right here be worth? These are going to be worth a millimeter, right? You understand that? Yes or no? And then how many of these do we have running around here? Well, here we got 50 of them. Right? You understand that? So we would do this the same way. So let's take this guy out of our Craftsman box, and let's see if we can measure this. So what I'm going to do is I'm going to put it. I think this will do it. I think it'll go out fast enough. It's going to be close, then. Okay, so we'll start off, we're gonna put it in there, and then,
Why would we put it in the tree?
huh?
Why would we-
No, cause it's just, we're just measuring the thickness of it, right? I'm gonna turn it till it clicks once, right? Right? Y'all see that? Everybody okay? Now, this is the locking mechanism, so a lot of times this thing is so easy to turn that if you want to come out and make your measurement and look at it like that, if you turn your thimble just a little bit, you're off, right? So what you would do, whatever you're measuring, if I could. So I put this across what I'm trying to measure. I rotate this until I get close, right? Okay. Then I move over to the thimble, right, to the clicks one. And then what you can do is you can come over here and lock that down. Now what you can do is you can bring your mic out and you don't have to worry about it doing what? Turning. Everybody see? So that's the lock right here, mechanism on this one. On the Craftsman, I'm trying to remember where the lock is on the Craftsman. It's on here somewhere. Yeah, it'll click when you get in here. But the lock on the Craftsman is this bottom ring right here.
Oh, yeah.
Yeah. So this is where you'd lock it right here. Right. You see what I'm talking about? On the Craftsman. So what does this measure? Everybody should measure about the same, right? So 20, I can't see, I'm sorry, 25, right?
I didn't do 12, started to say, sorry. 25.
Yep, so it'd be 0.25, right? Everybody okay? And then we don't have to add this. That would be 100, right? And then we'll come over here and look at this, and mine's on 40. Mine's on 41 and a half. Measuring this.
Ours is right at 39.
Yeah, well mine's on 41 and a half. I know y'all can't see it because of the glow. I don't know what to do about that. Which is okay. I mean, we're all, huh?
When you hold it up like that. And ours is a little under that.
Well, that's fine. I mean, good gracious.
It's a millimeter.
What you got to do is make sure you do it so it only clicks what? Once, right? Yeah, mine's coming in at the same place every time.
So 15 would be 0.15 there. And then each little, or in this case, 25, would be 0.25. And then we add, if there was more.
Right, then we'd lay everything together, right? You understand? So I'd start off with 0.25.
And if
Right.
it's the regular 25, you stop there on that. You don't.
Well, then you look at the thimble. Then you come over here and look at this guy right here. So if it was exactly 25, that would be down slightly below the 0.25, and then the thimble would be on 0. But my thimble's not on 0. My thimble's on what? On 30? When you measure this guy right here, mine's on 41.
Like you put the wrong, could it be, put two different, instead of this side here,
No, it shouldn't be any difference.
should be different.
No. Whether you put this guy or this guy in, because you're measuring the thickness of this rod. We okay? So what would this measure? What would mine measure? What would yours measure?
I mean, your rod look different from mine.
What's that?
You using this one?
No, you just,
The little, no, that's not the rod. Let me see what you got.
well, you're in.
It's just that this guy here's the,
Oh.
Mike down and zero it, see the man.
yeah, let me see. You gotta make sure you latch it down.
I had it last. Oh, you had it on 40 material.
Yeah, mine's a little, mine measures just a little. So what we do is we come in here and add all these together, right? Y'all understand? So what would we come up with? What does yours come up with? So first of all, I do what?
Find the,
I'd say 0.25, right? You understand that? And then each one of these would be worth a millimeter, right? You understand that? Everybody okay? I mean, I'm sorry. Each one of these would be worth, so that's 1 centimeter. So each one of these, oh, y'all can't see what I'm doing up here. So if this is 1 centimeter, each one of these would be 1 millimeter, right? 0.01, right? Everybody okay? And then I would come up, so I have none on mine, because I don't have another, I can't see the second line. So then I would come up here and I would add 0.041 on mine. So mine would be 291 millimeters, which is what mine would be. Make sense? So you do them exactly the same way, except one of them's in inches and one of them's in millimeters. Now, which one you run into when you get to the plant that you're at, you need to use the one on whatever they give you the specifications on these different devices, right? And of course, what we're going to do is we're going to measure our cubes. So how many different measurements do we need to make? We'll need to measure this, right? You understand? We need to measure what? This, and we need to measure this, right? And that would give you all the measurements. That's what you specify on these different drawings. We okay? Makes sense? So we got two different types of cubes over there. We have the metal ones, and then we have the acrylic ones. The acrylic ones should measure about the same this way and this way. Now, we've got other things that we'll look at in a minute, and that is being able to measure how big that hole is, right, and stuff like that. What we'll do over that is we'll move over to the caliper. Okay. So y'all go back and get y'all a couple of y'all's cubes. So it looks like this. So y'all see this? So first thing we want to do is take the thumb wheel, slide it up, and then see if it zeroes out when it touches. If it's not on zero, then we'll come up here and open this up, or loosen this up, and you adjust the outside till it's what? Zeroed out. Everybody okay? Yes or no? So this is a veneer caliper. This is outside, inside. So we use this one to measure we use this one to measure outside. We use this one to measure inside. Okay, that makes sense. So first thing we're going to do is check zero. So I'm going to take the little thumb wheel, I'm going to slide it up until it touches, and then I'm going to verify that my dial goes to zero. If it don't go to 0, then I come up here and this little set screw right here, I'll loosen it up and you turn the whole outside, right? Y'all see that? Yes or no? Until it sets on what? Sets on 0, and then make sure you lock it down wisely. So it won't accidentally move, right? Okay. So this side we use outside. We use this to measure outside. So if I wanted to measure this box, I would come up here and just put it like that until it touches, right? Then if I wanted to take away, here's your lock right here. So I could take this and screw this in to lock it so now it won't do what? Now it won't move. Everybody okay? That makes sense? With me so far?
Is there like a limit on the mystery?
What?
That part that opens up?
No, it'll open up. It'll open up this far right here. Huh? Yeah. Now, this, and normally they're smaller, this is a depth gauge. So we can actually use this to measure how deep something is, right? Everybody okay? This one will be sort of big. We'd have a little problem with this one getting small things. But anyway. So let's say, let's look. So we'll look at our scale.
Right. On the depth gauge, right there.
Yeah, well, we read it in the same place. So this is where we're going to read it at. So y'all see right here. Oh, sorry, so we're going to read right here. Here's the scale. This is what we're going to line up. The bottom right here. Let me find myself. So right here. Y'all see this guy right here?
Yeah.
This is what we're going to measure. So right now I have it on 2, almost 2. Okay, whoop, that's good. So right now I have it on 1. Right? Everybody okay? And what would this be? Well, I'm going to come over here and look at my thing. Oops. I don't have it on 1, guys. And if I got it exactly on 1, you notice it's 1 centimeter. So that'd be 100 millimeters, right? You understand that? Yes or no? Okay. So this is a lot like our what? Like our micrometer, right? Well, that means that these would all be worth what? 1 millimeter. This would be what? 10 millimeters, right? You understand? This would be 20 millimeters. So what I'd do the same way. So if I came over and got it right there, then what would this measure? Well, I would say 1, and then I see what? I see 1, 2, 3. I see 1, 2, 3 major marks, and then I'd come over here and read this. Now, I'm not sure why they did this one like this, because notice it goes from 1 to 0 here, right? So let's try to put it right here. So that's right. So it just repeats it. So this is exactly 1 millimeter. And then if I come on this side, that's exactly 2. So it don't make any difference which side of the scale is on. You just take the number. Everybody okay? Okay. So let's see what we got here. What did Earth measure? So I'm using my outside, right? Y'all see what I'm doing? And I've got mine, so this is 0.25. That's the last line I see. I'm doing the height again. Because we've measured this already, so we would have a good indication of what we're doing, right? So we should come up with pretty close to the same value that we did when we used our outside micrometer. Everybody okay?
So in this case, when you're adding the numbers, you have 1. Is it 1 or is it 0.1?
it would be 100 millimeters, which would be 0.1 centimeter.
Mr. Rich, so when you measure this, pretty sure like people who don't know will look at this gauge and try to get an answer after that. But it's not the right thing to do, right?
What's that?
Like,
No. You got to look at this guy here first, right? Just like what you do on your mic. So this is your major scales right here, right? You understand that?
so what does the gauge give our reading?
The gauge is your fractional. That would be like the little thumb wheel.
Okay,
So that would be like this guy right here on your mic.
I got you.
So these are your, right? Understand that makes sense? So if I measure the height right here, right? By the way, this guy here's, we move it up and it'll actually start slipping, right? You understand that? So when you get it, you got this major one, so you can move, as soon as I get here, I could use this guy to move it fairly fast. And then when I get close, then I'll shift over to what? This guy. And then I move it until it slips. Right? Y'all understand? Yes or no? That makes sense? Okay. Now, if I measure this, and then I could latch it down right here, right? Everybody okay? And then I may or may not. So this is what I got on mine. Can y'all read it?
That's what I have. Right at it.
0.25, right? Or 250, you could say. It's up to you. It's going to be in millimeters or centimeters, right? So that'd be 250, right? And then I'd come up here and read this right here. What would this be?
0.032.
Well, each one of these marks is worth 0.02 millimeters. Makes sense?
0.034.
Right. Well, mine's not on 4. Mine's on,
Mine's almost.
So
30.
we got almost the exact same.
should get almost the exact same thing that you measured on the micrometer. Right? Makes sense. Y'all get pretty close? Yeah, pretty neat, right? Now, this would be our inside mic. So if I wanted to measure the diameter of these holes, then I would come over here and I would come over here and just come over here and do what?
Put it in there.
Yeah, just touch it, right? You'll see that? And then this gives us the ability, then we do the same thing. We make the same measurement. Good gracious, that thing's almost 0.1. Yeah, almost 100 millimeters. So it's that's a 1 centimeter hole, right?
How far in there?
Well, what you want to do is, if you notice, you want to get it out on the out. It doesn't really make any difference. It depends on how far you can get it in there. But you can measure a pretty small hole, just by, y'all see what I'm talking about? So it all depends on how big the hole is, right? Does that make sense? So it don't hurt to put it in there like that. So that's, guys, that right there is pretty close to 100 millimeters, right? Which 1 centimeter. That makes sense?
Did you get able to cross one another?
They're supposed to cross one another. Yeah, they're supposed to cross one another. So they're supposed to cross one another. So what we're actually doing is, like I said though, but look, it depends on how far you get in there. It depends on what the diameter of the hole is. So we can measure a really small diameter hole, right? You understand? But you're only going to be able to get out on the very tip. On these, we can put it on in there and adjust it out. So they are going to crisscross, right? That makes sense? I'm talking the hole with the, which one? The little? No, mine's on 1. 0.7. It's got a. This was.
I was looking at the face. I was looking at the dial.
Don't look at the dial.
Yeah.
Read the major scale first, right? You understand? Now mine's a little off, but it's not. Mine would be 102 millimeters. 100. So this is pretty close to 1 millimeter. Now, we would have to go do something. This is a dial indicator, and we do read this exactly. We got 2 dials on it, one outside dial, one major and one minor. You'll see that? Yes or no? Now, normally what we use it, and this is a magnetic base that you can turn on, and it would clamp on to metal, or you can turn it off, right? You understand that? Everybody okay? Now, normally what we use this thing for is to measure, to see if something is, most of the time if it's at the right altitude or if it's lined up correctly. Does that make sense? Yes or no? Okay. Somebody said no. Yeah, so this is the stand. It's called a dial indicator. It's mounted on. As I can figure out how to mount this thing in here. This is the mount right here. It's been a long time since I've used this. Except, or you can go ahead and mount it on there. It's up to you. We're going to have to put all this back up. So this is a straight edge, right? You understand? What do we do this for? Well, you know, we can use these for making measurements. What I want you to do is take this one. This is a machinist ruler. And if you move your finger down there, you'll notice that this is actually grooved. So what's nice about a grooved one is, you know, we've got rulers over there now that we can't hardly use because what's happened? The paint now, the numbers have. So on a machinist ruler, you don't have to worry about that. These guys won't fade. You won't rub them off, right? You understand? This one we use for several different things. We can use it to see if something is aligned vertically, right? Like I think, oops, y'all don't see. One of the questions on your test was aligning the pulley. And if you have a straight edge, then what do you want to do on your pulleys? You just want to do what? Make them all 4 sides, right, on both sides of the pulleys. You want that lined up because if it's not, if you have a chain drive, so what do we call the things on the chain drive? We call them sprockets, right? You understand? And the multiplier you get, we can either multiply speed or we can multiply force, right? You understand that? Of course, rotation, we call that torque. It's determined by the size of the sprockets. And also, so on a belt drive, it's determined by the size of the pulleys, right? You understand that? So belt drives, we have pulleys, right? You understand that? Some people also call them sheaves. And then on chain drives, we call them, I think I got that. I think they are called, on belt drives, I think they're called sheaves, right? On chain drives, they're called sprockets. On pulley systems, that's where we, like cranes and stuff use. That's what we call those pulleys. Right? You understand? Now, the pulley system don't depend on the size. It depends on the number that you go through. Right? Everybody understand that? That's the compressor on the FANUC. How many times y'all heard that run? We got the FANUC in, shipped in, and they put it together. And we never, and first time we heard, I thought that was the quietest compressor I ever heard until it kicked in. That's a really good system on the FANUC. It's sealed up really good. So, a pulley, if you only got one pulley, what are you doing? Any speed modification? All you're doing is changing the direction of the pull, right? So you pull down on this side, it's gonna go up. But if you're lifting 100 pounds and you gotta generate 100 pounds force, right? Understand? If I come over here and add another pulley, I have to figure out how it would go. How would it go, guys? Huh? Yeah, but we're gonna run into each other. Well, this is a pulley system. These are ropes that we're pulling, right? Y'all understand that? But if we go through two pulleys, if I can figure out how they route, then we would divide by two, right? You understand? We would go half the speed, but twice the force, huh? More torque, but this would be, go ahead. Yeah, that's what I thought too, but if I come around like this, it's still going to collide. I don't know. But you have less torque. Yeah. And a lot of people don't understand that, that if you go to a bigger size wheel, you're actually going faster than you think you're going. Yeah, so the bigger your wheel's out, right? They didn't believe you? They didn't believe you? Yeah. Because they had big wheels on it? Yeah. So what you probably need to do is, what I recommend is that you can't recalibrate your speedometer, unfortunately. Well, you could if you took it into a shop or something and let them reprogram the engine control module. But what I recommend is just getting somebody behind you that has the right size wheels, and you just follow you, and get on your cell phone and say, well, then that way you could compensate for it. So the police officer was right. Okay, guys, so that's basically, there's some other instruments that we don't have. Inside mics, we have inside mics, that, these guys, I don't know if I've got a, so everybody okay on reading the rulers, right? These are in millimeters. So on these, how do we measure these? It always surprises me we have people that don't know how to use rulers. And this was one of the big things that we had when we was part of CARCAM before they disbanded. We had a big meeting down at Central Alabama Community College, and they brought in a bunch of manufacturers. And they was talking about the people in maintenance didn't know how to do what? Read a ruler. What? So, this guy right here is not near as accurate. This one is not a very accurate meter. So this would be 1 inch. So that guy right there would be a what? Half inch. This would be a what? 1/4 inch. That would be an 1/8, and that would be a 16th. The best rulers I've ever seen is goes down to 30 seconds. So if I come up here and measure the block, oops. Yeah, I think I've seen a 64 through. So what would this guy right here measure? Not quite. You gotta look.
1.25 inches.
No, it's, yeah, let me put this, it's not, it don't make any difference. I'm just saying, what will it measure? Oh, mine's not measuring 1 1/4 inch. Mine's less than 1 inch. Now, I'm using my finger to square it up, which might not be, it's pretty accurate, but mine's less than, huh? This is not 30, this is not 30 seconds. This is just, 8/16. So mine's measuring 15/16. Right? 15/16. Are we okay? So what would be what we call the height? Oh, that was the height, right? No. Okay, so what do we have to measure? Okay, there we go. So this would be can y'all see mine? Of course, y'all doing the same thing. 1 3/16. Yeah, so it'd be 1 3/16, right? Everybody okay? And then what would it measure on this guy right here? Now we measured this with our calipers of, our vernier. So this is 100 millimeters. That'd be 200 millimeters, right? Oops. And then, good gracious. So all we got?
3.
No, mine's not 3. Mine's over 3. 300. That's not 3. This is 300, right? Right. So mine's over 300 millimeters. Well, really? So the 30 is 3 centimeters. So that would be 300 millimeters. Right? Each one of these is 0.5 millimeters. So that tells us right there. What's that? Yeah, so this is 10. Mine's on 30. So that would be, I'm sorry. It's 30 millimeters. Yeah.
100. It would be 13. They've been 130. Yeah. Yeah. 13.
And this is in, and then the small scale is what?
Small scale is
half a millimeter, yeah. So mine looks like 31. Huh?
How much they get his car?
I don't know.
You can't buy the kit?
Not that I know of it. These are what comes along with the Boss trainers.
This was starter cut.
Yeah, and then we have, then we got this. This is, I think that's all our measurements. We got this. What's this? And what do we use torque wrenches for?
If Get that extra.
tighten bolts or nuts right down to precision, and that's very important. This is not in inch pounds. This is in newton meters. So most of the things now, if you look at the specs on these different boats, especially if you work on cars or motorcycles or anything like that, they'll give you the torque that you're supposed to be torquing these things down to. If you over torque them, then you got a problem. It might break or something like that. If you under torque them, then you got a problem with them coming loose, right? So y'all see how y'all do this, right? So this is where you set the maximum torque. Then how do you know when it meets it? Anybody know? It'll click on you, right? So you actually, it'll re-grab, but it just clicks, right? So as soon as it clicks once, that means what? It means you're good, right? Everybody okay on that?
So I'm line the 0 up with whatever foot pounds I want.
What's that?
So say if I want 20 foot pounds, I just line up to 0. Now,
If you want 20, yeah, you'd put the 0 on the 20, right? This would be 20.5, right? This would be 26. All right, so there's 10 between each one of them, right? Everybody okay? They'll say that? Lock is so you can lock it down and you don't accidentally turn it. You line up the bottom right here to whatever you want. So right now I've lined it up to 20, and then I put it on 0. So that would be 20 newton meters right there. Then I click it once, that would be 20.5, then 20, 21, 21.5, 22, 22.5, 23, 23.5, 24. And then now we're on the line on the right hand side. So you notice on the left, these runs in tens. On the other side, these are 20, 25, 30, 25, 35, 45, 55, right? You'll see that. So this runs in increments of 5 newton. So now mine is lined up on the 25. So that means I would be torquing the 25. I don't know if we can get it down far enough so I can actually turn it. Yeah, the best we can do is 10. Well, I wouldn't be able to break that loose. Oh yeah, I can. No. No, I can. The other thing that we have is these guys. And what do we call these? These are filler gauges. And what do we use these guys for? To measure the gap between something, right? Y'all understand that? So what we would do is we would take one of these. Anybody that's ever put spark plugs in a car, even now, you're supposed to do what? You're supposed to set the gap between the two electrodes. So this is in millimeters, right? You'll see that. So this would be what we do. We use these to measure the gap. Now you got to be real careful on these real thin, these guys right here. So this is the 0.015. And of course that's like aluminum foil, guys. You got to be real careful with that because you could actually tear it off accidentally, right? Everybody okay? And then of course, what else do we have in here? We have shims. And the shims are given different sizes. Oops. So what do we do with this? We use these to level things, right? Or set the gaps. If you ever put in a actual entrance door or inside your house, if you put in your entrance door, then a lot of times you have to do what? You have to shim it up. You can cut them yourself, or you can buy wood shims that you just tap in there to make sure your door is what? Square. So these are shims. Huh? Yeah. Shims usually stay in there. It's just like if you go back there right now, you'll see those shims and they stay in there until you do what? Until you move them. Yeah, or you come in and you take them back and you might have to shim it up again. We got some plastic shims on the Festo line over there because of the problem that we have on these lines is they don't give you the ability to adjust the altitude on the line. You know, when you get into these robots and everything, they have to be pretty perfect. But if you go and look at the Festo line, we got some plastic shims on one of the unit back there because the robot would keep missing it when it came over and picked it up. It wouldn't grab onto the cab. And we couldn't do what? We couldn't raise the module up. If we could have raised the module up a hair, we tried that for a while. We got some regular floor tiles and we put it under the wheels and raised them up, but that didn't work out. Especially if it comes to the point when we need to move them. So we used to set these are basically to set precision gaps. And like Christine said, these guys do what? They stay in there. So if you lose your 1.27 millimeter and you got it somewhere, you'll have to do what? You need to probably replace them. Everybody okay? Yes, no? So we got shims, we got filler gauges, we don't have any outside, we don't have any, what they call outside mics. I'll see if I can. Oh, this guy, thank you. Anybody know what this guy is? Somebody said it, what? This is a belt tension tester. So, of course, one of the things that what's the basic way most people do to check the tension on the belt? You push on it, right? But sometimes the belt will give you a spec and says you need to run it under this much tension. This is where the push on it don't really work, right? And also the slack in a chain. Chains are not supposed to have any slack in them. Well, that's not true. They'll slack a little bit. So you don't want a chain to be really, really tight because what will happen? It'll wear the rollers out. The little seals between the rollers in between the chains will wear out. And of course, if you don't align the chain, then it's going to wear out your teeth on your sprocket, right? You understand if it's not aligned correctly. So this is a tension tester. Not only could you use it to check the tension on a belt, you could also use it to check the tension on a spring. So how do you read this, guys? Yeah, so that's this is your little latch right here. So we push, like Anthony said, we push it up to the top, we push down, and then we come back and then we can read the ring. Y'all can see what I'm doing, right? You see what he said? Push the little O-ring up to the top. And then when you push it on your belt, you push it down. And then when you let it go, the ring stays where you was at, from there. And then you can come up and read your tension. I don't know what this tension is right here. Does it tell us? So this guy here is in inches. So what you do is your tension is set by how much deflection you get on the belt. Everybody understand that? Deflection you get on the belt.
Ring pretty fast as far as like taking space.
Well, you're exactly right, and I think what you would do is you'd read the top of the ring, not the bottom of the ring. We okay? Any more things in the kit?
The level of the meter.
And of course, we have the level, right? Everybody knows how to use the level, right? What you're shooting for is the bubble to be what? In the middle, between the two lines. We okay? We okay? Oh, mine's not bad. It's not perfectly level, but. What? There's a metal file in there.
Yes.
So we got a meter, everybody knows how to use the meters.
Next to the court.
Then we have a standard tape, right?
Thanks. Thanks, Dan. You got metric on two.
What is this called?
It's called,
A what?
it's called technically it's called a combination wrench. Yeah, because you both have, you have the teeth, right, and then you have the, okay? Anything else we have in there?
That's it.
I have no idea what this is. We would have to look in.
Came with the dial.
Yeah. So we got the belt tension or the chain tension. We got the micrometer, right? Yeah, we got Allen wrenches in there, but that's not what we do, right? And we got 3/8 ratchet. Okay, guys, the next lab we're going to do, we'll go ahead. So everybody's here. So we'll figure out the. So here's the input output. So this is the electrical. This shows us how our inputs or outputs are wired up to our PLC. And it also shows us the terminal blocks that it goes to. Okay. So here's our inputs, right? This will show you which metric, which terminal it goes to. Of course, we know 0 through 3 are our inputs, and then 4 or 5 are the outputs, right? Right. So here's our outputs. And this is the electrical symbol of a directional control valve. That's the little valve. And then right here is the solenoid. So I notice if it's got 2 of them, and that means it's got to be, which, and the thing that we shift in the center, we call that the what? The spool. Line. This is what it actually puts together. And I don't see my camera, guys. So this is the valves that are line put together. Then, so this is manually operated. This has a spring return on it, right? You understand? So I'm manually operating this. Well, what are we doing? We're shifting this thing right here, which we call the spool. And what the spool's doing is either doing what? Directing air out this port, or it's going to direct air out the other one. If it's directing air out of the other one, then the other one would be the exhaust, right? You understand that? And that's what we're doing is when we're shifting this, we're shifting the location of the spool. Now you don't see the exhaust on this because it exhausts through the valve. So this would be a 4-port valve. You just don't see the exhaust, right? You understand that? And this would be a 2-position valve because we able to come up here and shift it this direction or we shift it that, right? Now what we do with the solenoid is generating a linear force. So what we do is we use a solenoid to push it that way. And then use a what? Use a spring to bring it back. Or we do what? We put solenoids on both sides. So this guy would be this guy would be manually operated with a spring return. So on the electrical, that thing in the center, that is the valve. That's basically the spool, right? You understand? And then they'll give us the symbol. And like I said, the guy that drew this up used the wrong symbol. Where is it at? Okay. Here it is. This right here should have a slash line through it, right? You understand that? So this is the valve. This is the solenoid operated. Since this has only got a solenoid on one side, then this has got to be what? Spring return, right? You understand? Everybody okay? Makes sense. So when we look at the the pneumatic, these are the actual pneumatics. Here we go. So this is the valve right here. And these are drawn right. So this is a symbol for a what? Spring. This is the symbol for a solenoid. What's this guy right here?
Right above 1v1.
This guy right here.
What?
This is a manual override. So if you over and look on these valves, it's got a little hole on the side that we can literally do what? Manually override. And like we said, guys, when you do a manual override, you need to understand the consequences, because when you manual override these things, an actuator is going to move somewhere, right? You understand that? Y'all understand that? So this is a 4-port valve, so this would be 2 position. So what we do when we identify the valves, we start off with the number of ports. How many ports does it have? 4. Then we start off with the number of positions we can put it in. 2, and then we use the term way. Then we come back and say that. So we'd say this is a 4 two-way valve. That's the way you'd buy it, 4 two-way valve. With manual operated with spring return. Solenoid operated with spring return. And most of them will come with a manual override, so I'd have to figure that out. Everybody okay? And that's all they use on this line is the 4-port two-way valves. That's all they use on this whole line. What would be the maximum number of positions we could put a valve in? So all you either have 2-position valves or you have 3-position valves, guys, and that's it. And, the most we will have would either be, it depends on whether they share exhaust or not. The most ports you'll have is 5. If they share the same exhaust, then you'd still have 4. So a 5-port valve would have 2 exhaust ports. And they do that because if you're routing the exhaust, you're going to route it to one side, and you have to move it through a tube, right? You understand? You get friction. So the advantage of a 5-port valve would be that it exhausts the same thing on both sides. And another advantage is that when we meter out, right? You understand? So what we could do is if we meter, what does that mean on a pneumatic system? Meter out. So what are these guys right here? These are unidirectional flow control valves, which means they control the flow in one direction and they bypass the other direction. Okay. And what do we meter? Do we meter the exhaust or do we meter the pressure? Okay, so this is pneumatics. Pneumatics has to stay under pressure. The problem is if I meter the pressure, as soon as the solenoid moves, as soon as the actuator moves, then it uncompresses. And then I have to pressurize it again. So on pneumatics, if we meter in, your actuators are going to be really jerky. They're going to jerk like that because they're going to move. As soon as they move, it uncompresses, right? You understand? And then it's got to recompress it, right? You understand that? The air. So what we do on pneumatics is we always meter out. We meter the exhaust. So now your pressure is always pushing against something, right? You understand? So you're pushing against that flow control valve. So in the expression is when in doubt, meter out. Hydraulics don't care because hydraulics generates pressure when you use it. Pneumatics, we have to pressurize before we use it. And as soon as your actuator moves, if you're not pushing against something, then what's going to happen? It's going to unpressurize and then you'll have to repressurize. So normally we meter out except for single acting cylinders. On single acting cylinders, guys, we've only got one option. That's to do what? Meter in. Because you don't get the exhaust. Right? You understand that? We got a couple of single acting cylinders. So what we're going to do is we're going to come up here and we're going to R&R one of these valves. And what we're going to do is we're going to move one in the center. So the gripe, I've written up the gripe already. It says actuator will not move. And through your troubleshooting, you've determined that it's what? The valve. You don't know what's wrong with it, but you determined it's the valve. Now, it could be several things. We're going to replace the whole valve. And you're going to have to, it's got the cable ties on there. So what are you probably going to have to do? Might have to cut them. We'll see. By the way, these things have little mechanical latches on them, and you'll have to get one of these little, let me unpause this and go show you.